Rahim. Question is at June 15 and variant 43, question number 3, and in worksheet question number 110. So let's start. A car of mass 860 kilograms. So mass is given 860. Okay. Traveling in a horizontal straight road. Okay. And the power provided by the car engine is power P. So power is P watt. No problem. And friction resistance to motion is R. So frictional force is given by him is R, newtons. Okay. Car passes through a point with a speed of 4, speed 4.5. So speed is given here at which point? Any point you can say that. So velocity is given here 4.5 meter per second. And that moment same acceleration is a 4 meter per second square. Okay, another point, car passes through another point with speed of 22 point. It means this is let's say I given A. So velocity at A and acceleration at A. Now I talk about velocity at a B, second point. So what is velocity given here? Passes through another speed is 22.5 meter per second. And at that point, acceleration is given 0. Acceleration at B is given 0.3 meter per second square. So I wrote whole data, and my target is a P and R to get it. Okay, so let's see how we can get it. The plan is very, very clear. Okay, now I'll give an idea. So we know that what is a basic formula when you're going horizontal straight path. Okay, so whenever situation is this, so applied force backward is a frictional force is equal to ma. So I say that net force equal to ma, and this is very, very clear. But force power formula all in F into V. If I bring this down, so force equal to power by V. But let's talk about at A. Okay, so I can say that power at A by velocity at A, friction is throughout constant, and mass times to acceleration at A. So just plug in the values. Power is throughout same, and velocity at A is given here 4.5. So 4.5, and friction force given R, and mass is 860, and acceleration at A is 4. Okay, so if I check it, 860 into 4 become 3. Okay, now I have to reshape it and get the answer. So this R comes, okay, first number step by step, 4.5 minus R in 3440. So this 4.5 is just disturbing throughout a multiply whole equation. Into this, cancel. Into this, 4.5 R. Into that, into 4.5, it turns to be 15480. Equation number 1 ready. Same manner, I talk about B. So at B. So now I'm writing directly power at B divided by power at velocity at a B, and friction is same, mass same, and B. So I think idea is clear. Power, power, and velocity at B is we know it. It is given here 22.5. 22.5, and friction force we know is R, mass 860 into acceleration, that is 0.3. So let me check 0.3, yeah, 0.3. So now into this whole equation, so power remains same here, 22.5 times 2 R, in here 860 into 0.3 into 22.5, I get 5805. Equation number 2 ready. Now I'll solve them simultaneously. So let's solve. So 1 minus 2. So P minus 4.5 R 15480, and P minus 22.5 R is equal to 5805. So because I'm subtracting, so change the sign, this minus, this plus, and this minus. And then what happens? This power cancels. So let me check 15480 minus this, it turns to be 9675, whereas 22.5 minus 4.5, it becomes 18R. So 9675 divided by 18, I get R value. R value is coming 537.5 newtons. So this R is done. Similar manner, if I plug this value in any one equation, let's plug in here. Okay, so let's see what answers then. So this value into 4.5 and add in that. So into 4.5 and plus 15480. The answers coming power is 1789898.75 watt. Okay, but I don't need, in this I need a kilowatt. So power becomes 3 jumps, 1, 2, and 3. It turns to be 17.9 kilowatt, 9 kilowatt. And R is very clear, 3SF, so 5, 3, 8 newtons. So we got the answer correct, and that question is completely over.